In this video, we're going to graph both square root and cube root transformations. So to begin, let's take a look at the square and cube root parent functions. So you can see that we have the square root function here and the cube root function here. Now typically when we make parent functions, we look at the x values from -2 to 2. But here I choose to do something a little bit different. If you would like to look at the x values from -2 to 2, that is perfectly fine. When I make my table here, I actually pick values that are a little more purposeful. Now I know that when dealing with an even root, this is an even root of 2, that I can't have any negative numbers here. So I'm not going to include any negative numbers underneath the root because I realistically know that those are going to spit out something with a domain error and it's not going to work. So I'm going to start my x values with 0 instead. Now I know that the square root of 0 is 0, so there I have my first point right there. Now, I like to make things a little bit easier on myself, so as I select x values for my parent graph, I'm going to pick x values that I know are really easy to square root. So for example, the next really easy to square root value would be 1. The square root of 1 is 1, so my next point would be right here at 1, 1. Then the next really easy value to square root for x is 4. The square root of 4 is 2, so I'm going to go to x is 4, y is 2. Then the next one that's really easy to square root is 9. Square root of 9 is 3. So I go to x is 9, y is 3. And then if you want to do one more, you can do, x is 16, that's the next easy one, y is 4. And as I said, you don't need to use those same x values. I just choose to use the easy to root values because for me, those are quicker to root and quicker to remember. Now, a couple of things I need to remember as I draw this graph. 1, there are no negative values allowed. So that means that I am not going to draw my graph anywhere over here. Those are values I cannot use. So my graph kind of has a stopping point here at 0, 0. So as I draw my graph here, I'm going to note that my graph is only going to extend to the right. So I'm going to start here at 0, 0, cut through my points, and there it goes. And I have an arrow on one side. So you can see that it's a very slow going graph that moves only to the right. Now the last thing that I need to find here are my domain and my range. Remember, the domain represents all of the x values that we use to make points on our graph, and our range represents all of the y values that we use to make points on our graph. And what I notice as I look here is that my x values start at 0 and then move only to the right. I'm not using any of the negative x values, so my domain is x is greater than or equal to 0 because the only x values I use start at 0 and are then larger than 0. And then my y values for my range are similar. They start at 0, 0, and they only go up. I don't use any of those negative y values, so I have y is greater than or equal to 0. So now that we've mastered the square root parent function, let's take a look at that cube root parent function over here. Now, a couple of things I know about the cube root function that's different is that negative values are allowed here. So because it's an odd root, negative values are allowed. So I need to make sure that I look at what happens on both the negative and positive side of x. So what I'm going to do here is I'm going to create a table. And you can use -2 to 2 if you would like. I'm going to use values that are a little bit different, that are easier to cube root. So I'm going to start by putting 0 in the middle because I know I want to get values on both the negative and the positive side of 0. And I'm going to start with the cube root of 0. Well, I know that the cube root of 0 is in fact 0. So that's going to be about right here. Then I'm going to think, okay, what are the next values around 0 that can be easily cube rooted? And I think of 1. The cube root of 1 is 1. So that's going to be my next point here. And then I think on the other side, well, I can cube root -1. And the cube root of -1 is -1 because -1 times itself 3 times gives me -1. So I have 2 additional points there. Then I think, okay, what's the next one? Well, 2, 3, 4, none of those are easily cube rooted. The next number that's easily cube rooted is 8, because the cube root of 8 is 2. So I'm going to go to x is 8, y is 2. And then on the other side of it, negative 8, if we take the cube root of negative 8, would be negative 2, because negative 2 times negative 2 times negative 2 gives us negative 8. So there we have our graphs. You'll notice that even though these are both roots, they look very different. So we see here that this kind of comes through and shoots to the right. This one comes through and shoots very slowly to the left. So we have two very different parent functions, even though they're both made up of roots. Now, to end here, we need to find our domain of the cube root function, and what I notice is that it goes forever to both the left and the right. So our domain is all real numbers, because every single x value to the left and the right is being used. And then our range is also all real numbers, because it's going forever up and down. It's going slowly forever up and down, but it is going forever up and down. So we're going to use these two parent functions as we look at transformations of both square root and cube root functions throughout the rest of this video. So what you see on the screen here is a table you've seen before. Now it's just tailored to the square root and cube root functions. And they are dealing with all of the different transformations that we can apply to a graph. So we have horizontal and vertical translations, reflections over both axes, and then vertical and horizontal stretches and shrinks. So just to give you a quick recap of these, remember that translations move the graph left, right, up, and down. Vertical translations are going to happen outside of parentheses, or in this case, outside of the root. You can see that there. They work just as expected. Positive moves up, negative moves down. The horizontal translations happen inside parentheses, or in this case, inside of the root, and they work opposite as you expect. So a negative would move you to the right, and a positive would move you to the left. Then if we take a look at reflections, we have both horizontal and vertical reflections. A horizontal reflection is going to happen over the y-axis. You can see that because you flip horizontally. And a vertical reflection happens over the x-axis. So you can see because that happens up and down. Now, remember, a horizontal, anything horizontal is going to happen inside parentheses or inside the root. So this is our horizontal reflection. So in this case, you can see we're multiplying the inside of that root by a negative number. Just be very careful with that. Now that we have some restricted domains, this won't always be allowed. It could result in some values inside of an even root that do not work. But if you have a vertical reflection that's multiplying the outside by a -1, that's when we go over the x-axis, and those are going to flip the graph over the x-axis and just multiply all the values outside of the root by -1. Then we have vertical and horizontal stretches and shrinks. Vertical, remember, happens on the outside of your parentheses or the outside of your root, and horizontal happens here on the inside of your root. Vertical works just as expected. If it's a small number like a third, it's a shrink. If it's a bigger number like 2, it's a stretch. Remember, the way to easily tell is by its relationship with 1. So if it's a number whose distance from 0 is less than 1 unit, it's going to be a shrink down. And if it's more than 1 unit, it's going to be a stretch up. Horizontal stretches and shrinks work kind of the opposite of what we expect. Remember, you have to use that b value on the inside to find your factor. So in this case, b is equal to 2. So you can see it says b equals 1 over your factor. Well, the other way to flip it around is that your factor that you are shrinking or stretching by is equal to 1 over your b value. So in this case, it's 1 over 2. They are reciprocals of each other. So if you have a 2 here, you flip it to its reciprocal, it becomes 1/2, so it's a shrink. If you have 1/3, you flip it to its reciprocal, so it is 3 over 1, so it is a stretch. This is your crash course on transformations in case you forgot. And then we're going to move forward and actually apply these to different graphs. So here in this first example, we're going to describe our transformation to start, and then we're going to draw a sketch of it by using the parent graph. So the first thing I notice is that this is a square root because it doesn't have a number there, so it's going to be my square root parent function that I use as a reference. Then from here, I note that I have two values, a 3 and a -2. Well, we've talked a lot in this course about a, b, h, and k. I know that this 3 here is my h value, which really represents a horizontal translation. So because I'm adding a value inside of the root, I know that that's how it's moving left and right. And I know that adding inside the root is the opposite of what I expect. So this is going to be a movement to the left or a negative direction, 3. And then this value right here, this -2, is my k. Because I'm adding or subtracting it on the outside, that's going to be a vertical movement up or down, and this is going to move the parent function down 2. So what I expect to see here is I expect to see my graph moved left 3, down 2. I don't see any sort of reflections, or I don't see any sort of stretches or shrinks here, so it's just moving it left 3, down 2. So remember, when we start these, we always start with our parent graph. So I'm going to go back to my earlier notes and record my parent graph. Now remember, I did not use the traditional -2 to 2. I was a little more purposeful and used positive values because a even root can't take in negative values. And then I only used the values that were really easy to square root, basically. So this became square root of 0 is 0, 1, 2, 3, and 4. So now I'm going to translate this graph by using the transformations that I wrote down. So here I can see that I'm moving the graph to the left 3. Now remember, moving it left 3 is going to change my x value, and that's going to move it in the negative direction. So I'm going to subtract 3 from all of my x values. So here, as I transform my graph, I'm going to write a new one over here. I'm going to take all of these values and I'm going to subtract 3 from them as I move them over here. So I have -3, -2, 1, 6, and 13. Then I know that I'm also moving my graph down. So because I'm moving it down, I'm going to move my y value down 2. So I'm going to need to subtract 2 from all of those. So I do -2, -1, 0, 1, and 2. So now I'm going to go to my graph and actually plot this new function. So I go to x is -3, y is -2. There's my starting point. That's where my 0, 0 start point moved. Then I have x is -2, y is -1. Then I have x is 1, y is 0. X is 6, y is 1. And if you want to try to fit this last one on here, x is 13, y is 2. So I can see here that I have my starting point. Remember that this is where we start. A square root graph does not extend to the left. And then my graph fully extends here only to the right. So I have a starting point of -3, -2, and then it only extends to the right. So we can see that our parent graph, our original square root graph, moved left 3, down 2, just as our transformations predicted. Now our final thing here is to find our domain and our range. Our domain, we can see that our x values here start at -3 and move to the right only. They do not move to the left. So our domain is x is greater than or equal to -3, because the only x values we use are -3 and greater. And then our y values are greater than or equal to -2, because we start here at -2 and our graph only goes up, it does not go down. So let's dive in here and take a look at number 2. So here I notice that I have a value being multiplied out in front that is a -1/2. This negative value here is telling me that I have a reflection of sorts over the x-axis, because I have a vertical reflection since it is outside. And then the 1/2 is telling me that I have an A value of 1/2 that is going to be a vertical shrink, again, because it is outside of the root. Then from here, I also have a value on the inside that is being added. So this is my H value here, and this is going to move the graph horizontally because it's inside of the root, and because it's negative, it's going to move it in the positive direction, which in this case is going to be right 4 units. So those are the transformations that I expect to see. So to start here, I'm going to go straight to my parent graph. And remember, this parent graph does go into the negative values. If I reference my notes, I notice that I only selected x values that are easy to root. So I picked 0 in the middle, and then I put -1 and 1, -8 and 8, because those were the easy to root numbers that I could put inside of my root. So my parent function produced -2, -1, 0, 1, and 2. So I'm now going to apply my transformations one at a time. So I'm going to start with this multiplication out in front. Remember, we always start with any reflections and or stretches and shrinks. So what I'm going to do here, because I have a vertical reflection and a vertical shrink, those both happen vertically to the y value. They encompass this -1/2. So I'm going to take my vertical values, or my y values, and multiply them by -1/2. So as I do that, I'm going to produce a new table with y values that are shrunk down and reflected. So if I multiply -2 by -1/2, I get 1. Here I get 0.5, 0, -0.5, and -1. And I haven't changed my x values, so those all stay the same. Then from here, I'm going to now transform my graph with its horizontal translation, which is moving it to the right 4. So since it's horizontal, it's going to happen to my x values, and because I'm moving to the right 4, I'm going to add 4 here to each of these x values. So as I do that, I do -8 plus 4 is -4, -1 plus 4 is 3, that becomes 4, 5, and 12. Then my y values here do not change, as they've already been changed as they needed to. So here I have my final table for my child graph. So I go over, I go to -4, 1, that's right there. 3.5, so that doesn't move very much, that's right there. 4, 0, 5, -0.5, and then I have to go to 12 out here to get to -1. So I can see it's been reflected, it's kind of twisted the other direction now, and then it moved to the right 4. So if I draw my graph here, I can see that taking place. So my last step here is to find my domain and my range. I can see it's going forever left and right and forever up and down. So my domain and my range are both all real numbers. Okay, third and final example here. So I notice right away that there is a multiplication of 3 here inside of the root. I know when I multiply inside of the root that that is a horizontal stretch or shrink. I also remember that this needs to be flipped to its reciprocal. So this is a factor of 1/3, which tells me that it is a horizontal shrink by a factor of 1/3. I also notice that I have a 1 here on the outside. Because it's being added on the outside, I know that it is a vertical translation, and it's going to be moving the graph up 1. So now let's take a look at our parent function so that we can begin transforming it. So I know that I have the cube root, so I'm going to use my cube root parent function. So I know that for that one I can use both negative and positive values. So I start with 0, 0 in the center, and then I branched out to -1 and -8, and 1 and 8 on the positive side. So now I can start performing my transformations. I notice this first one is a horizontal shrink. So horizontal shrinks are going to happen to x because x is our horizontal value, and we're going to multiply it by 1/3 to shrink those down. So if we multiply all of our x values by a third, negative 8 times a third becomes negative 8 over 3, which is about negative 2.66 repeating. Then negative 1 times a third becomes negative 0.33 repeating. Then we get 0, 0.33 repeating. And then 8 times 1/3 is about 2.66 repeating. So those shrunk way down. Now our y values haven't been changed yet, so we're going to leave those just as is. So now we have applied all of our strengths and our stretches and our reflections that we see. So now we're going to vertically translate this graph up 1. So we take all of our y values and we add 1 to them. So those become negative 1, 0, 1, 2, and 3. And then our x values here stay the same. So now if we go and plot those, x is negative 2.66, y is negative 1. So that's about right there. X is negative 0.33, y is 0, so that's about right there. Then you have x is 0, y is 1, so that's about there. And then you have 0.3 and 2, so that's really close right there. And then you have 2.66 and 3, which is about right there. So you can see it gets really skinny and scrunched up near the y-axis there. So because this is a cube root, it extends in both directions. So we can see that the graph shrunk in horizontally. And then here our domain and our range are both all real numbers because it's extending forever in both directions.